Hello guys, what's up? Welcome to Mathology Overflow and the first set of lectures on combinatorics. These lectures are designed for anyone preparing for math competitions. The best way to do math is to solve problems. So unlike other lectures which follow a theory then problems format, we will follow the opposite, problems then theory format. And I personally believe deriving the theory from the first principles as much as possible. Without further ado, let's dive into the world of combinatorics. First, let's look at the brief outline of the course. As I said a few seconds back, the best way to do math is to solve problems, and this is especially the case with combinatorics. So what is combinatorics? We study counting. Yes, that's right. We count the number of ways of arrangement of a set of objects. We are usually concerned with questions like how many, the number of ways, and many such similar questions. So let's move on to the first set of very basic problems. Let's start with our first problem. How many numbers are there from 1 to 20? This is a very basic problem. You can go ahead with noting down the numbers 1, 2, 3, 4, 5, 6, all the way up to 20. And you can easily count, and hence you would have 20 numbers. Let's look at the next problem. How many numbers are there from 5 to 20? We can proceed similarly as before, noting down the numbers 5, 6, 7, 8, 9, all the way up to 20. We can count them one by one, and it counts to 16. But say we are asked the same for 16 to 1000, counting every number becomes unrealistic. Can we get a formula for this? Is it 20 minus 5? Let's think about it a bit. Let us call this sequence as S1. We would like to convert or translate this sequence into another sequence S2, which starts with 1. What operation can we do? We need to convert this 5 into 1. Yes, you are right. We need to subtract 4 from 5. In fact, we can subtract 4 from every number of S1. We would get the sequence S2 as 1, 2, 3, 4, 5, all the way till 16. Now we can see there are 16 numbers in the sequence. So 20 minus 5 is wrong. There's one extra as we are including both the ends, 5 as well as 20. So 20 minus 5 plus 1, 16 is the right answer. Let's take a look at problem 3. We can write the sequence S1 as A plus 1, A plus 2, all the way up to B. As we did previously, let's try to convert S1 into a sequence S2 which starts with 1. Once again, what operation can we do over here? We need to subtract A minus 1 from A to get 1. Similarly, if we subtract A minus 1 from every number in the sequence. This becomes 1, this becomes 2, this becomes 3, and this becomes b minus a plus 1. As we can see, there are b minus a plus 1 numbers in the sequence. We simply translated the given sequence S1 into S2 by some operation, just to make our life easier. Let's move on to the next problem. Well, there's a new term here, inclusive. It means A and B are included, essentially a reframing of the previous problem. The previous problem says how many numbers are there from A to B, and it included A as well as B. When we say how many numbers are there between A and B inclusive, it exactly means the same thing. How many numbers are there from A to B? So essentially, B minus A plus 1 is also the answer here. Time for the next one. Alright, so now we have a negative number over here. We are asked how many numbers are there from minus 5 to 20. Let's take our first sequence, S1, which starts from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, all the way up to 20. One can count from minus 5 to minus 1 as 5 numbers, 0 as 1 number, and 1 to 20 as 20 numbers, and then summing these 3 up, which is essentially 26. That's right. But let's look at it in another fashion. Let's try to convert the minus 5 to 1. What operation do we need to do? We can either deduct minus 6 from minus 5 or add 6 to minus 5. And if we do this particular operation to all the numbers in sequence 1, we would get a new sequence S2 as 1, 2, 3, 4, 5, 0 becomes 6, 1 becomes 7, 2 becomes 8, and 20 becomes 26. So we have our new sequence, which is from 1 to 26, and hence we can also say there are 26 numbers. In all of these problems above, we have tried to convert a given problem to an easier problem by some sort of an operation. Alright, let's move ahead. I guess it's time to now look at multiples and count multiples. Alright, so the first problem is asking us how many multiples of 10 are there between 10 and 100 inclusive. So from 10 to 100, how many multiples of 10 are there? One can start writing down the sequence as 10, 20, 30, all the way to 100. We can translate this sequence to another sequence S2. We can divide all these numbers by 10, and we would get 1, 2, 3 up till 10. This makes our life a lot easier, since there are 10 numbers in the sequence. Alright, so what about 9 and 100 inclusive? Well, 9 is exactly not a multiple of 10, but 100 is. We need to find the next multiple of 10, which is greater than 9. That's 10. So our S1 becomes 10, 20, 30, all the way till 100. And essentially it becomes the previous problem. We can translate this to 1, 2, all the way till 10, and we have our 10 numbers. How about 11 to 100 inclusive? Well, once again, 11 is not a multiple of 10, but 100 is. So we need to figure out the next multiple of 10 that is greater than 11. That's 20. So our S1 becomes 20, 30, 40, all the way till 100. Our S2 becomes 2, 3, all the way till 10. We translated S1 into S2 by dividing every element of S1 by 10. At this stage, we could easily find out how many numbers are there from 2 to 10. It's b minus a plus 1, so we could say 10 minus 2 plus 1, that's equals to 9. But one can go ahead and for better clarity, can subtract 1 from every element of S2, which will give us a new S3 as 1, 2 till 9, which gives us 9 numbers. A very important note for the students over here. Many people try to create some sort of a wrong approach or a wrong trick or a wrong shortcut by blindly writing 100 minus 20 by 10, where 100 is the upper multiple, 20 is the lower multiple over here, which is greater than 11. They take the difference between the two and divide by 10 because it's asking for multiples of 10. And they arrive at the wrong answer. Be very careful while dealing with such counting of multiples problem. I would leave the next problem to you. Please comment down below. How did you approach the problem? How did you solve the problem? What about problem 0.6.0? We are asked to find the number of 3-digit squares. So 3 digits, 3 digits we know from 100 to 999. Well, 100 is a perfect square. 999 is not. So we need to find the previous square which is less than 999. I guess we need some hit and trial over here. Let's see. We know 10 square is 100. We know 20 square as 400. We know 30 square is 900. Let's see if we could do better. What about 31 square? Well, if you calculate, that's 961. How about 32 square? That's 1024. That's greater than 999. So this cannot be within our bounds. So 31 square is what we are looking for over here. So our sequence becomes 10, 11, all the way up to 31. And we can easily see, since 10 and 31 are included in the sequence, There are 31 minus 10 plus 1, 22 numbers in this sequence. Give 0.6.1 a try and comment down your approach. That's all for the first video. We will look at some elementary but key concepts in the following videos. If you have some suggestions for improvement, please comment down below. Feel free to ask any questions, your doubts. If you like the content, show some love. Please like and share the video with your friends, subscribe to this channel, and stay tuned